Hey everyone, I'm Neil. I'm a partner at D-Box. We're the creative directors of the marketing for this project. Our responsibility was the development of high-resolution images, designing and producing the books and other materials, and our founder, Matthew Bannister, is the creative director of the entire project, and he's leading the architectural design team. We've now been on this project for 4 years.
Hello, everyone. My name is Jos Uribe. I'm Jos Uribe, founder of PureBlink, and our task in this very special project was to take all the marketing visuals, the beautiful work from D-Box, and convert it into a unique VR experience.
Hi, everyone. My name is Alex Coulomb. I run an XR creative studio in New York City called Agilens Immersive Design. And our role in this project was to take all the beautiful work that PureBlink produced and then unify it all together into one virtual reality experience in the custom showroom that we'll be speaking more about today.
So this is the end result of all of the work that we did. It's a VR experience space which takes potential buyers on a tour through various residences, the clubhouse on the lake, the fitness center with golf simulators, pickleball, and basketball courts, the restaurant overlooking the lake in downtown Austin, and the private movie theater. There's no teleporting within the same space. They're all laid out one-to-one, fully walkable. Each scene is designed to overlap in a way with consistent start and end points, and guests are tracked so that they can see each other. Eventually, at the end of the 20-minute presentation, they're invited to sit in the chair from the movie theater where the virtual version lines up exactly with the one in the real world. The client did order a set of seats from the movie theater just for this purpose. So first up, before we get into the technical part, I'm going to give some context to the development and why a 5,000 square foot space with no teleporting was necessary to aid in the marketing of this development. This is the location of the project. It's upriver from downtown Austin, located on the top of a hill at the bend in the river. The site itself is 145 acres with 3,000 feet of shoreline and a 380-foot hilltop. These are the views from the site, and it's not possible to overstate how incredible this is. You get up there and look around, and you realize it's the best site all the way to the horizon. You're right at the bend in the river, so it arcs around in front of you with downtown Austin planted dead center in a valley of rolling hills. And this is the planned development. The master plan, which we designed at D-Box, is such that from the living rooms, there is no other architecture that shoulders your view. So from every residence, you feel like you're the only home on top of the hill. There are 175 units, averaging over 6,000 square feet a unit. Every unit is a flow-through unit, following the ridge line of the site, making sure everyone in the Lakeview residences has a completely unobstructed view. Starting from the Garden Plaza, there's a portal moment where the view to downtown Austin is framed by the architecture. And from there, you can take a 2-minute funicular ride down to the marina and the lake clubhouse. Or you can enter the upper clubhouse, where there's a private restaurant, a theater, and a theater lounge. And so some of the features that make this a particular challenge to represent are that these are condos, but a great deal of effort has been placed into making them feel like standalone residences. The residences on the ground floor have gardens with a pool, yet due to their position on the hilltop, they still maintain an elevated view of the lake in downtown Austin, as if we're in a 33-story tall tower. You're in a building that's 4 stories tall, which at most is shared with 6 to 8 other homes, but your perspective of downtown is that of being in the penthouse of a luxury tower. And there's no precedent for this. No one's experienced that before, to know what that feels like, to be in a home that feels like a single-family house, yet with the views of a tower. The penthouses are up to 7,000 square feet with 3,000 square feet of terrace and a private 40-foot lap pool with an infinity edge looking out towards downtown Austin. There are 100,000 square feet of amenities, which alone are costing $400 million. They are broken into 4 distinct clubs. There's the lake clubhouse, the upper clubhouse, the spa and wellness and sports. So there's 4 clubs in one on this property, each with their own incredible spaces. And the amenity package is really the most impressive part of the entire development. I've barely scratched the surface of the full scope, and it couldn't be richer or more extensive. There's nothing like this in the entire world. So how do you communicate how that feels to walk into when there's zero precedent or things to compare it to? And we're telling the story of what it's like to live on vacation at a fully private resort, which is close to a major city. You can't tell that in still renderings or with a typical film. Like, floor plans and renderings only go so far to communicate how a project might differ from something. They're great for extrapolation, but a flat digital representation for something that's never been done before, they fall a little bit short. So the developer from very early on knew the only way to communicate this was through VR. It's not just a value add to the sales experience, it's solving a real problem. The potential buyers, after they experience the full tour and get to walk all of these spaces in VR, when they leave VR and get ready to go home, they feel like they've actually been somewhere. They're left with like a real emotional response. and hopefully somewhere they'd like to live permanently. And so it's important to point out the level of design and planning that had to go into this project before any of this VR could even start. Jonathan, our client, recognized the potential of this site back in 2015 and started purchasing the land. By 2018, the design process started and has been ongoing until today. The vision was for a private community of residences following the ridgeline, ensuring that every residence has a great view. And the entire project was designed in VR. We used Prospect for this, taking into account sightlines, view corridors, and what things would look like from every vantage point. The design team in the early stages would jump in as a team remotely from all over the world and move around massing and making sure that views of downtown Austin were framed and always as good as they could be. Every possible opportunity to create a more significant moment or experience while on the property was taken. This shows how views of the famous Pennybacker Bridge were maintained. The only way to really demonstrate how thorough and carefully designed this project is without having built it for real is to allow people to walk it for real. And the point of all this is that by the time we could even think about creating a VR experience space, well over 200 people have worked on this, all following the same vision, and it's been in progress for 8 years. This is just a short list of all the teams involved. And you might be wondering why that's relevant, but a critical fact that this comes from is that there's no shortcuts. We can't just simplify geometry or change materials to enable a more efficient workflow. All the details of how things are constructed down to the hinges used in the doors are already selected and all need to be custom created and represented appropriately. Potential buyers have seen physical samples of the materials, the stones, and the woods, and we can't simplify them for the sake of a few extra frames per second. Accuracy and detail was a critical cornerstone of the whole process. And so jumping to last year, D-Box has been on the project for 4 years, and the client reminds us that his ultimate goal was to be able to represent the project in full room scale VR. And at this point, I feel like it's worth pointing out that our marketing renders take anywhere from 8 to 14 hours of V-Ray, and our poly counts, well, we don't have a budget. And at D-Box, we tried every automated, easy method we could to generate volumes and simple baked environments, but none were good enough. From fairly early on, we'd been doing stereo 360 renders. These were nice and quick, very easy to generate with a very low turnaround time, but they couldn't be used for something that needed to be as immersive as this. We explored volume-based rendering and automated bakes, and while they had a full 6 degrees of freedom, the lack of shaders and reflections really held it back. And the client wanted full walkable room scale VR with ray tracing. It had to be done in Unreal Engine. While I and a few others at D-Box know our way around Unreal a bit, we know that it's a big lift and we can't just wing it, figuring it out as we go. Plus, I am allergic to unwrapping UVs and I shouldn't do it anymore. So we got a big list of everyone who's doing interesting things in VR for real estate, and we set up a test scene. We took the 120 million polygon Lakeview East residence, we packaged a max file with all the assets, and we set them loose on it. The brief was to make this real time in VR. The reflections have to look great, light has to be fantastic, use Unreal 4 or 5, it doesn't matter. And so I want to comment on our client briefly. This is Jonathan Kuhn. His company is called Impossible Ventures, and I think already you can tell the kind of person he is a little bit. He genuinely loves the challenge of taking on tasks that nobody has done before. He founded a company called 1-800-CONTACTS. He sold it. He also produced and funded the movie Napoleon Dynamite. The key thing here is that he's incredibly tech savvy, he's very hands-on, and he's nurtured people learning on the job in a way other developers wouldn't do. Now, we had a client that was maniacal about making this work. He had this incredible drive to make sure everything could work as well as it does. There was no giving up. If one path didn't work, it was time to look for a new one and continue exhausting every possibility. Any other clients would have walked away many times over, but Jonathan pushed on and basically built a tech startup to see his vision through.
So I've been in the virtual reality industry for about 10 years now, and it's still a relatively small community. So when a very ambitious luxury project comes along, you hear rumblings about it, and it permeates the ether. And so starting about this time last year, I started to hear from people like Shane Scranton at Iris VR, you saw Prospect earlier, Jeff Model, formerly of CG Architect, Paul DeBevic, Kim Bellman-Larson, and Vikas Reddy, and then finally Jeff Powers, who finally gave me an introduction to Jonathan. And I immediately loved the scope and ambition of what what him and D-Box were trying to accomplish. So we set to work doing the scene that had been provided, but we didn't know that there were multiple teams all doing the same scene. This kind of A/B testing is very typical for the focus that someone like Jonathan can bring to a project like this, where he wants to make sure he's going to get the best possible result, the diligence, so to speak. And so I started to get connected after about a month of R&D through my contacts at Epic with various other companies that seemed to be trying to achieve the same very ambitious level of a VR project. And so these kinds of emails were being passed around where it's like, oh, what a coincidence. We're also trying to do a similar project like that. Maybe we can help each other out. And then, of course, we learned later on that the goal here was to take all these different firms that were working on that and then ultimately select one. But fortunately for us, it ended up being both AgileLens and PureBlink, and it's been a great collaboration ever since.
Yeah, and you were super, super collaborative and open, so thank you for that, Alex. So let's go back in time to November last year. We received the brief from D-Box, and at the time we had been working for about, let's say, since 2015 in Unreal, little by little, we started introducing into our pipeline all the projects that were taken into the interactive field. We started working with Unreal, then we moved to film, then we moved to VR. The previous VR experience that we had done up to this point was 2 years before that. But from the brief, what we understood, like we had this same presentation, the idea, the goal was to create 10 different scenes or more than 10 scenes, starting with a demo that had to be developed in VR within 3 to 4 months. It was a unique luxury project, and I think that this is very important because it goes hand in hand with that idea of not taking any shortcuts. That means that materials, furniture, accessories, everything had to be just according to the specifications that were coming from the renderings. The performance had to be set at 90 frames per second at 4K. It had to be a multiplayer experience. And most importantly, the VR needs to feel even better than the D-Box renderings. What? Okay, I don't know how many of you are from the architectural visualization industry, but for all those of you that don't know, D-Box has been inspiring architects, visualization companies, 3D artists for the past 25 years, myself included. When I founded the company 20 years ago, I remember that I started searching for companies that could combine design, visualization, architecture into one single studio, but still be a creative studio. Back then, this is 1999, 2000, I remember I found two firms, D-Box and KD Lab. And ever since then, I started following their work. Then I had the opportunity to talk to Matthew, and I understood where all this creativity and inspiration came from. So this project was very important for us and for me because it was an opportunity to collaborate with someone that has been an inspiration. But also, it was very, very important because I knew that this was not an atypical project for a visualization company. D-Box was in charge of the marketing, and Matthew was leading the design team. So this was a project that was very close to his heart, very close and dear to his heart, and it quickly became one that was very close to ours. So it was definitely not a piece of cake. It was definitely a challenge that we had to take. When we saw a brief that was very descriptive in terms of how this space had to feel so hyper-realistic so that at the end of the experience, people would think that they just came back from another place. We're like, well, this is an impossible venture. And that's, like, there couldn't be a better name for the company that Jonathan Kuhn drives, because this couldn't have been made without the vision, the perseverance, the persistence that Jonathan has. The word persistence and perseverance has a completely different meaning when you start working with him. So what do we do? Okay, Well, first, the very first question is establishing a pipeline. Like, do we use Unreal 4 or 5? We were very excited with 5, with all the different features, Lumen, the dynamic lighting, nanite. I guess maybe this is very easy, and we started working with that. So at the end, what we really wanted to know is, whatever path we take, it needs to be very stable. It needs to give us the performance that we are required. It needs to be very realistic. The reflections and the refractions are very important. And at that time, that was a big question, because the previous VR project that we had done 2 years before, we couldn't achieve getting ray tracing in VR. We had a short deadline, and the lighting and illumination needed to work for all different spaces. We had pools, spas, but also the bright spaces of the units. So the only way to do this, we needed to start doing R&D, testing and testing and testing. And the very first test, and we did a whole bunch of tests at this stage. I'm just going to go through a couple of slides. But of course, we started with 5. We started with a scene that was more or less, that was transferred in nanite. But we quickly understood that Lumen didn't really have the performance that we were requiring. As soon as you start lowering the settings for Lumen, then you start having all these different artifacts in the global illumination that were even more present when you have reflections on chrome elements. So our test was always this globe, like 2 globes, one that was made out of glass, like very refractive, and the other one very reflective. On the refractive surface, this is a sphere made out of glass, and as you can see, the refraction here is extremely flat. Raster refractions didn't really work for us. So when we connected this to ray trace, then we started seeing all these different problems. We had this milky type of refractions that were not ideal at all. Then we tried different tips that we were getting as instant stereo. Instant stereo doesn't work. It collides with ray trace. Then we tried, OK, so let's stay in Unreal 5, but let's use GPU light mask, and let's use a baked light and see how that works. But what happens is that nanite doesn't really work that well with the refractions and the reflections with ray trace. And soon we realized that Unreal 5 was really going to be very tricky at that time in order to make this work. So when we started testing this with our old friend of 427, this is what we got. Nice refractions, nice reflections. We could limit and play the number of bounces on the reflections. There was some opportunity to be flexible, yet we would be achieving this was closer to the end results that we wanted to have. So, well, here's a chart of different comparisons, and this is just like a summary of all these different elements. Now, take this with a grain of salt, because these tests were done from November all the way to January this year. Now, in Unreal Engine words, like the 10 months, it's a lot. It's like 20 decades. Because within this time span, there's been 3 new versions. Now, I'm sure that there's going to be a question about, oh, what about Unreal 5.3? Is this VR ready? The short answer is no. Lumen still doesn't have that performance, but it's getting very close. Many of the bugs that we identified here have been adjusted and corrected by the amazing developers of Epic. So maybe next year we will have one with nanite and so on in VR. Now, lighting in VR. There are so many things that are completely different when you do a marketing rendering or a marketing video than a VR experience. Lighting is definitely one of them. And lighting was very important, because one of the things that Divox is recognized for is to have this very soft and subtle light that illuminates the space. Of course, when you compare when you're working in an offline rendering, as Neil mentioned, the pipeline was 3D Studio Max and V-Ray. The base rendering would take anywhere from 7 to 8 hours, depending on the computer. And then on top of that, there's the post-production process that, depending on the image and the intention, it can take from, I don't know, an hour, maybe 4, 8 hours.
Maybe a whole day.
Yeah, maybe a whole day. And another part that was critical was that this space, we receive like this is only 5, but I believe that we had even more, like close to 10 different views and renderings of all the different spaces. If we're going to go with GPU light mask and it has to be backlight, then we cannot have dynamic lighting. We need to set on one single set of light. Like what was the position of the sun, what was the ideal position of the sun, and how would this affect the perception. Lighting in a still rendering, as some of you will know, may know, is one of the most important elements in order to drive the user's attention, in order to drive the composition. And that was carefully placed by Divock's team. So how do we bring this into the VR experience? What we decided to do was, this project is very particular because it sits on top of the hill. The light that you get there is beautiful, and it's one of the few places where you get this very horizontal line, even before, or like hours before the sunset, because of its position. The relationship with the view was also very, very critical. And we really wanted to capture a very bright space. So we really liked the lighting that was happening here on the bottom right corner, with that very kind of warm light that illuminates the space, but yet the white balance is still all in place. So that was our first challenge. We were like, okay, let's take this rendering and let's do it in GPU light mask in Unreal, and let's try to achieve the same result. Now, this is the base rendering, and this is what happens with the post-production. So these are all the different layers that, that we received from the post-production files that were also very important for us. For all those that are not familiar with this process, the post-production is always done in order to enhance the image and, again, try to bring the attention of the viewer to specific points. But our challenge was to bring our Unreal experience to the final frame of that post-production in real time, 90 frames per second at 4K, using a 4090. So we did a lot of tests on the lighting, and when we got to this point, I was very happy. And actually, I was very surprised because, yes, there are some differences here and there, but we tried not to have cinematographic lighting. So if you're familiar with cinematography, like you can really play with the light. You can really have flags, diffusers, bouncers in order to define one single area. But in this case, you're going to be walking all around. So the light had to be very realistic, and we had to only rely to that specific lighting positioning and post-processing. What do you think? Which one is the version from Unreal, and which one is the version Divock's rendering? Top is from Unreal? Okay, and woo! So everyone that said bottom, yes, you're right. There are some differences, and yeah, you'll see them in a second. Okay, next on, big chapter, ray trace. Is the breaking the ray trace myth in VR. So when we started this process, again, we started consulting with different people at Epic and some of our peers. And we said, well, yes, this is going to be it's a custom luxury project. And it's going to be, we had to hit 90 frames per second in VR. And we need to use ray trace. I was like, oh, no, you cannot use ray trace. We started reviewing all the documentation, and ray trace is not only part of the bad practices, but it's definitely not recommended. Like, if you're going to use VR, don't use ray trace. And we kept reading that all over the place, and that's part of the reasons why we started doing these tests. But now that we had to test with different areas, and once we optimized or semi-optimized one of the scenes, we did more tests in order to see if we needed to optimize even further the mesh. Another aspect that we learned on in the documentation from Unreal, it says that one of the recommendations is to have instant stereo on, but actually instant stereo really clashes with ray trace. As soon as you have ray trace and instant stereo activated, you just don't see the refraction on one eye. And after working on a while, this was one of our results where we have reflections, refractions, reflections on the oven. We really like that we could have the ability to limit the bounces on the reflections. Later on, depending on the scene, we could go all the way up to 5 bounces or sometimes 3, but that also was related to the level of optimization. Everything was okay until we see this beautiful space. This is the marketing rendering from Divox of the ensuite washroom, which is a beautiful space, but it's a ray trace nightmare because you have confronting mirrors seeing each other, so you have these infinite reflections. Right in the middle, you have this glass shower with refractions and reflections as well. But the most important part of this was the view. Everything was designed in order for the view to be the main protagonist of the space. And the view is also, again, through another set of panels of glass. So we didn't really know if we were going to hit the performance here. But again, we found out that, yes, again, limiting the number of bounces on reflections from roughness, there was a point where our performance was lost. So we decided to keep it at 3 bounces and have reflection capture at the end so that it could just mimic that idea of the infinite reflection without having the infinite reflections. The refractions don't really work quite well in ray trace, especially when you have the reflection of a refractive element. So we just, and they also bring the performance extremely down. It was we had a very, very low performance as soon as we activated that. So what we decided to do was turning off the refractions, the translucency, and turning off the translucency in the ray trace reflections, and that helped us achieve that. And we had to just be creative on how we show the reflection of the shower. Okay, now, no matter how you set the ray tracing, or no matter the limitations on the ray trace, I forgot another very important variable on ray trace. That's the maximum distance. So the maximum distance, let me go back. The maximum distance really defines the area that the ray trace will be calculated. And this was extremely useful as well. Just a couple of tips that we were learning along the way. But none of these would really quite work if we don't have a very optimized geometry. And here the modeling team was really part of the artists. Like we engaged them in such a way so that they could really understand the nature of not only the architecture or the interior design, but the entire space. Every single detail mattered. And the challenge that we had was that we had all these different scenes came from over 100 million polygons per scene. And our benchmarks after doing all these different R&D was we needed to hit at not more than 10 million triangles per view. And the assets had to be under 100,000 triangles. And we couldn't have more than 1,000 draw calls. That was our limitation. So we had to be very creative in order to work on this. And that meant not only modeling or optimizing meshes or remodeling meshes with good topology, but really using a lot of gaming techniques in order to help us and assist us on our challenge. So for example, we have 2 chairs here that are almost identical, and that was another part of the challenge. Every single object had to look great from the distance, but also in VR, you don't really know what people are going to see. And when you're in VR, you really go like, oh, look at this detail. And, oh, this is beautiful. Oh, it's dusty, right? So every single detail counted. Now, when we say low poly, we usually think, oh, it's going to have a lower level of detail, which is true. But there are so many tips and tricks that we've learned from gaming techniques that really allows us to bring even a further level of detail. So we have on one side 700,000 triangles that was converted into 60,000. And here we did it again using bumps and height bumps on low poly techniques. The detail is really fantastic. As you can see, this is the high res version. But this is the low res. So sometimes, and this was a big change on the modeling team, because the modeling team, especially if they come from the architectural visualization, you tend to model absolutely everything. It was say, oh, it has threads. Oh, okay, so I need to model the threads. No, there's a level of detail, and we could, again, we had to go in this type of exercise through all the different furniture and accessories. These are just a couple of examples. This is the original climbing wall that we will find in the sports lounge. It had almost 1.4 million triangles, and it got converted to only 67 triangles. We used techniques like projecting the high-res mall into a low-res mall, using instances. We eliminated all the different holes that we had for the fingers on the climbing wall, and created maps and bump maps. So the idea is really that every single detail had to look great when you're very close to it. But it also had to look great from different perspectives, from different angles. And these are all like just a compilation of different series of details that we have. And every single one of them created a challenge. But nothing is more challenging than plants. Because plants are organic, and plants are beautiful. And when something is beautiful in a VR space, you tend to gravitate there. You go like, oh, that's a beautiful plant. And part of the review sessions that we had with Jonathan and Matthew and the entire team was we would receive all these 20-minute videos of them walking around, and it's like, oh, but this is not right, this is not right. And plants was a huge component of that. So for plants, in some we tried doing low poly techniques, we tried remodeling them, but everything was going great up to we get to this beautiful scene. The orangery, this is the pool that the design is quite great because it's also surrounded by vegetation. You have all these beautiful orange plants that surround the pool. And the light in this area is kind of mystical because you can imagine the mist from the pool with the light that is coming from one side of the pool area. On the other side, we have also reflections. So not only this place is filled with vegetation, but we have reflections, refractions, the reflections of the pool. It was quite a challenge. And this one was, to be honest, the only scene that we didn't really know if we were going to make it. I mean, at the beginning, we didn't know if we were going to make any of these. But as we kept on progressing, we were like very confident that this could really work up to this scene. So the max file had over 160 million triangles. Every single tree had over 5 million triangles. Now, another part that was very important for this is that the trees look great on the rendering because they were used from that one point perspective. But when you start walking around, this was the level of detail that we would get. So not only they were extremely high poly, but the level of detail when you were up close was not the desired one. And we had the pool with mirrors, reflections, and refractions. So we tried remodeling everything from scratch, but the performance was not really, we were not really achieving the performance, so we decided to remodel every single plant using procedural techniques. And here's where we have to say, well, SpeedTree came to the rescue. The great thing about modeling plants and vegetation in SpeedTree is that you can have one single model, and you can, depending on the settings that you have on the different nodes, you can have all the levels of details on that same model. So from that same model, we could create the different, like we set it up so that we have 3 levels of detail, but at the same time, in the areas where when we were walking around, we knew that the lower part of the tree had to be very high poly or very well defined, but then we don't really care about the leaves that are way up above. So we had also 3 levels of detail in depending on the height. And it was great. Again, we didn't want every single tree to feel the same. So the procedural techniques that we have, or the way that you model with speed tree, it really allows you to create different organic forms in a very quick and efficient way. And the game's version for speed tree works like a charm in Unreal. This was the only place where, in all the other scenes, the users can walk freely all around, but this was the only place where we decided to have 3 different levels of optimization. LOD 0 is the high level 1, the LOD 1 is intermediate, and LOD 2 is low poly. And another thing that we really liked about this is that even with the 3 levels of optimization, it doesn't change the silhouette. Like from the distance, it feels almost like the same type of tree. And if you thought that that was the only place where we had plants, no. This place, the architecture is very connected to nature, so plants were a very big component, and these are just like screen grabs from the VR experience of all the different places that we had where we had nature. So again, we wanted to bring all these different elements in order to have a more immersive experience. Sound is very important, as you all know. So we started introducing spatial sound so that it would relate to the activities that we had in that particular area, or it could tell that there are some other activities in the area. So all the sound was done in spatial sound. There were some critical areas where we wanted to bring the attention of the user, so that's where we placed the sound. But again, it works, and it really gives you this idea of how, the spatial qualities of the space. And this was also beautiful for this connection between the interior and the exterior, the connection to nature, the flow of the water, and so on. In terms of the theater was also challenging because we decided to go with light, with GPU light mask, with all the light baked. So how do you have that dynamism? How do you have that dynamic light? We wanted the experience to start with all the lights turned on and then be able to turn them off and have the different videos there. So what we decided to do was animating the exposure change, or animating the exposure, and animating also the video screen material intensity. And by doing that, it's not 100% hyperreal, but when you're there, it feels right. Another big component was the video ambient lighting plugin that we used for the video, because it was very critical that if we're watching a movie, if we're seeing this space, the space is fully illuminated by the video. And this is the area, and Alex is going to expand on this, where you actually get to sit in these same type of chairs. So the level of detail of these chairs had to be, was also critical. So the reality is that none of these videos nor images can really express the experience that you are going to have when you are inside the VR experience. The only way to experience this is by buying one unit at the Four Seasons Private Residences Lake Austin project, or be in their private appointments for the VR experience. But what we decided to here was we quickly put together a video using the same model, the same type of lighting, with 64 samples, and we only introduced the FOV and a little bit of bloom effects on some scenes, but we wanted just to keep it as close as possible to the actual file. So.
applause, right? It's nice. So, buckle up, everyone. I'm going to go through a lot of stuff very fast. Apologies to everyone in the room. Everyone who watches this on YouTube later, I recommend turning the speed down to about 0.25. So while everything was happening with PureBlink and they were up to creating this beautiful, gorgeous work, we were wrestling with rainbows. We're over in New York City in places like Zero Space, trying to figure out how to achieve arena-scale, large multiplayer tracking. We started by testing things like the Quest 2 controller, which has a very nice relationship with the headset. We'd have everyone go and put the controller down on the ground, 0, 0, 0, 0, 0, 0. We all have the same origin now. Great, I can walk around. Here's a chair. I'm going to keep walking around. The chair's still there. But then the actual headset that ended up being used was a MetaQuest Pro, and that meant that we couldn't actually use that IR relationship between the headset and the controller. So as we started to try to create a shared coordinate system, that wasn't going to function. We also tried shared spatial anchors for Meta. That was not available to us either. But we were constantly producing diagrams and documents like this where we would kind of show what would happen with drift, how we'd move through a space, what kind of things we needed in order to have the most successful results. And by the time we made it to Austin, right around South by Southwest, spoiler alert, did not spend a lot of time at South by Southwest, we were in a temporary space starting to set up an anti-latency system, which started to produce a bit of a shared coordinate system, kind of a ground truth reference for where everyone was going to be as they walk around the space. So these little green IR lights around the ceiling, that basically becomes a very unique pattern, which is what you want when tracking in VR, so that we could all walk around and have this experience look well. Marshall Nowak on our team became a 3D printing expert. He produced this little way to hold the little IR diode on top of the headsets, and everything looked pretty good in the main space. And then, as we tested that, we realized, yes, of course, as you started to pick the headset up and down, the virtual headset and the physical headset aligned pretty well. So we're feeling pretty good. We're moving out of the temporary space. We're going to the actual showroom. Wow, everything's so beautiful. It looks great. But we did find pretty quickly, despite the fact that everything looked gorgeous, especially when we got into the mood lighting mode, that it was essentially a tent pretending to be a building. And if we enhance the little video in the bottom right, we had this little thing that would happen sometimes when it was windy. And do you think it was windy very often? Well, it's a tent on a cliff. So yes. And you can imagine if that's your ground truth reference for what all your shared coordinate system would be, not a great time to be inside of VR. So we moved on from anti-latency, jumped into OptiTrack. For those who don't know, OptiTrack is popularly used in motion capture and whatnot, turning people like Josh Brolin into Thanos. And we thought this would be pretty straightforward because we didn't even need to track the whole body of everyone in the multiplayer experience. We just needed to know where all the headsets were. So as everyone walked around, everything was where it was supposed to be expected. We installed a truss. We brought in great folks from 209 to be able to set this all up with us. And it was a very quick turnaround time because tours needed to start happening soon. So we essentially had all this equipment overnighted. Some of the cameras were the ones we wanted. Some of them were what were available. And we tried to cover as much of the sight lines of what was available in the space. And then it was basically a rush over this 2-week period to get everything set up with our team in Austin to have everything working. We had to learn motive software. We didn't even know what that was before, and we started to use all these different setups to basically figure out how successful the tracking was as we moved around. Marshall then went on to create this great little mount system for the MetaQuest Pro so that we could use the active pucks on top to move around, but they were a little bit shaky. They weren't as perfect as could have been, and Jonathan, being as fastidious and detail-oriented as he is, said, this could probably be better, right? So then we said, instead of just having a mount for the existing active tracker, what if we actually started to design the casing? What if we got, say a few 3D printers and started to really experiment with different ways to track and make sure people are going to be able to occlude each other and move around the space and still have the tracking working as well as possible. So the final version was this kind of antler mount system, which looked wonderful, especially if anyone was in the basketball court and wanted to try to shoot a jump shot. In the 3D printing community, there's a little thing called a Vegetation. This stands for F that, I'll just print it, which is usually the case when there's some weird problem that you're having trouble solving. In this case, it was that the MetaQuest Pro has this fun little quirk where the power button and the volume button are right where people put their thumbs when they put the headset on. So everything's set up, everything's perfect. Someone goes in for a tour and they put on the headset and they say, it's black, or they say it's muted. And it's something they did, but we can't really blame them. It's just not the ideal design. So Marshall then designed this great little Vegetation, which I also have several of if anyone wants one. If anyone has a MetaQuest Pro, and this basically prevented anyone from doing that. The server room, which was originally just supposed to house the computers that were powering the experience, these custom RTX 4090 Puget workstations, mwah, very lovely, then started to also become a place for 3D printing and figuring out where all the Nighthawk routers were going to go and wiring things through the walls and having backups of everything, Motive. And then we had Cope and Carlos and this great team in Austin so that I could bring my folks back to New York, and we installed them there to kind of run the day-to-day tours, and they've been going well all summer. And so then as we started to think about combining all these scenes that PureBlink had put together into one unified experience, we found the build size was getting pretty big, around 55 gigabytes all in. That's not the project size, that's the build size. So you can imagine, especially over in 4.27, we don't have access to things in Unreal Engine 5 like the Zen loader, so the asynchronous loading of the maps became a bit of a challenge. Also, if you use a typical multiplayer system with a server and a client, it does this fun little thing where the clients don't even start to load the next map until the server has already loaded the map. So we built our own custom multiplayer system out of OSC, which basically makes everyone think that they're in a single player experience, even though there is actually a full multiplayer set of signals going out to everyone. And then in order to cut down on the load time wait as you go from scene to scene, we had this kind of interstitial space that you could see the renders from D-Box, and the host could kind of have this green laser pointer and talk about, we're going to go into here, we're going to move through here. And what started as what felt like a bug, like, oh, I can't believe we have to wait for this next scene to load, really started to feel like a very nice feature. It became a bit of a palate cleanser between each scene. It built up anticipation and tension and excitement for what you were about to experience in VR. And then you get to go from that D-Box render into seeing that whole world come to life around you. In the bottom right, you see some of the footprints. We'll talk more about that in a second, which was to make sure that everyone was standing in the right place as we start to move around. The drift still was a problem here. So OptiTrack is great. It's not really designed for finding out where people are frame by frame. It's more for like vectors and motion. And so we found that the MetaQuest inside-out tracking, the time warp, et cetera, was really good at helping to take the 45 frames per second being targeted, reprojecting them to 90, and making the experience feel comfortable. But then we still had to deal with drift. So that's where OptiTrack came in. But we didn't want to take OptiTrack every single frame because that made it feel really jittery. And if we tried to do any kind of sensor fusion solution, that didn't work well either. So essentially the idea was to say, we're going to make sure the host can see what kind of drift everyone is dealing with. And then at any given moment, if they say, oh, okay, we need to recalibrate, they could press a button and then kind of snap everyone back into place. Then we prevent people from walking into walls or into each other, and it just becomes a better experience overall. But the entire OptiTrack system there is only for those moments of calibration, just for realigning everything. And very briefly with the diagram here, the green headset is to show the host where each client is within the experience. So if they're admiring a beautiful chair, looking really closely over here like Jose was demonstrating, then the client might, or the host may know to comment on that and say, here's what that material is, here's how that's made. But then the black headset is to make sure that everyone still has that kind of awe moment of peeking under their headset and seeing that everyone is aligned with where they're supposed to be. The clients would only see the black headsets. They wouldn't see the white or the green headsets. That's just for the host. So then the white headset would be where OptiTrack thinks the headsets are. So that's what the host would be monitoring, trying to figure out how far off are people from where they're supposed to be, and starting to understand that at any given moment, it might be worth calibrating everyone or just that person and just giving everyone the most comfortable experience as they go through. For you math nerds out here, here's a little bit of like the vector math. If Jose and I were standing next to each other in the experience and I drifted by 1 degree off a rotation, if we walked forward for the duration of the holodeck, we would then be a little over a foot off from each other. And because we have people moving around the space all the time, that becomes a bit of a problem. You might have been to actual VR gaming arcade spaces before where there's a lot of contrast and a lot of crazy shapes. That is to help with the tracking. But in our space, it's a little bit of a QR code chic look that's kind of got this art gallery feel to it, and it does mean a lot of repetitive surfaces. So we had to find ways to improve the tracking, and one of the ways we did that was by looking at heat maps of how people were moving through the space, and then looking for places that we could add additional fiducial markers, these things that look like QR codes, in places where the controllers and the headset would see them and therefore get more tracking, but they wouldn't be in places where people would step, because you don't want to break immersion by having a different texture on the floor from what is consistent everywhere else. And so these are actually diagrams that Neil put together where we had to figure out that despite the fact that 5,000 square feet is a plenty large showroom, it was not enough to actually cover all the spaces that we wanted people to be able to walk through. So Neil would put down these plans and start to figure out, okay, if someone's standing here, then we teleport them to the next scene, then they're going to be here, and then they'll be able to walk over and see these spaces. So this was a really fun little Rubik's Cube of a puzzle to figure out how everyone would move throughout the space. And just to show that a little bit in practice, this is what it looks like in the sports lounge when the host would then say, okay, everyone, I'm gonna make some feet appear on the ground. Everyone come over, stand on your feet for what, turn it is for us to do something. And then that's the only time artificial locomotion is used, is to bring people from one place to another, in this case over into the basketball court. Just takes a second, and then everything feels pretty good. We would also do that when going from the interstitial spaces into new ones. And then finally, as we've already alluded to, this theater moment is a really wonderful finale to the whole experience. You've been walking around looking at these beautiful spaces, and then all of a sudden, these chairs from Figueres, shipped from Spain, are actually physically there, and you get to sit down. So here's June on our team demonstrating the alignment of the chairs to the actual space, and just the tactility and the sense of premium quality you get from being there. And so then what would happen is we'd start to have people come through, and you guide them in. You might recalibrate them for a second just to make sure everything's aligned. But a lot of the techniques being used here to align it are traditions as old as time, things like spike tape on the ground. And fun fact, when I got my start doing virtual reality, it was for theaters and allowing people to do things like grab a physical theater chair and sit down and stand up. So this felt very natural and looked absolutely beautiful as a final showcase of what was being offered in the experience. You're seeing essentially a 60-foot LED screen, this premium sound system, but it's all being done with the headset you have on and the physical sound system there, which is a little better than the natural Quest audio. So then if you thought, okay, that seems like a fun challenge, how about taking it on tour? How about taking everything that went into that very custom single showroom space and bringing it for just a few days to a hotel ballroom in Aspen? No problem, right? Well, here's a little bit of what that looked like. So the build for this was literally just a couple days to basically reassemble everything that was done over months in Austin. And then there was something like 10 tours a day bringing people through just for everyone who wasn't in Austin at the time, already in Aspen, would rather be in Aspen. You can see how much of this was recreated one-to-one, though there was a special build that was put together just to make this work as well as possible. There we are. So thank you so much, everyone. We hope you've enjoyed this presentation. We'll be sticking around after for questions. Cheers.